So we're going to look today is a summary of my latest book. I call it the greatest untold story of the 21st century. That is of the benefits that are accruing to humanity and the ecosystems for modest warming and more CO2. And again, that's drawn from my latest book, A Very Convenient Warming. And we just had Success Boeken has just published it in Dutch, and it's available today. So who is the CO2 Coalition? I'm the executive director. We've got more than 170 of the top scientists in the world. The gentleman at the top left is Dr. Patrick Moore, a co-founder of Greenpeace, sits on our board. He believes as I do. Dr. John Clauser to the top right is 2022 Nobel laureate in physics. Hard to call him a science denier. And of course, Dr. William Happer is our chair. He's at the bottom left. Many of you know of Dr. Happer. We work together daily. He's I call him an American icon. He really is, what he's done. We've actually got, we're assisting Clintel. We've got an affidavit right now at The Hague in the lawsuit going on there right now that Clintel's involved with. We also were concerned about the science education in America, but around the world, that our children and grandchildren were being indoctrinated into a climate cult, that they were being taught group thinking, consensus thinking, instead of critical thinking skills. And so what we've done, we've actually published in several ways. We're out reaching out to homeschool communities, charter schools, and public schools. We have a series of books, a series of videos, and importantly, we have lesson plans we've created to go along with those. So what we're going to talk about today, we're talking about the new climate tyranny that aims to control every aspect of your life. I mean, they want to control what you drive, what you eat, how you heat your home, how much water comes out of your shower, how much water you use in your dishwasher. It's all about control. And so what we're going to talk about today, and this is a billboard we put up in the United States in several large cities: sleep well, there is no climate crisis. We had at this spot, there were 130 cars or vehicles that went by this every day. So people were about breaking their neck and heads were exploding. So we're proud of that. Today we'll look at three central elements: carbon dioxide, what's going on, what happened in the past; temperature, what are we seeing; and then importantly, the benefits of the combination of modest warming and more CO2. And so if we look at carbon dioxide, going back to the beginning of the Industrial Revolution, it was about 280 parts per million at that point. We're at 420 today, so that's a 50% increase. And importantly, look at the right-hand side here. It's somewhat of an orangish color. It was in the mid-20th century, in that post-World War II economic boom, where we saw a real increase in carbon dioxide. And for these slides today, if it's blue, like it is here, that's carbon dioxide. Temperature will be in red, just to key you in on this. And if we look over the last several 100,000 years, we see that the carbon dioxide levels we have today are significantly higher than they were in the other interglacial periods between the glacial advances. So there's something different going on now. And I will argue, and my fellows at the CO2 Coalition will argue, it's us and our emissions. So what is the source of this 50% increase since 1800? It's us, and mainly emissions of carbon dioxide from burning fossil fuels. And we can prove this. We have a paper coming out soon. And in fact, Dr. Ferdinand Engelbein is in the room, and he's the lead author of this paper. He's the expert on it. I'm drawing on some of his knowledge. He lives in, I believe, Antwerp. But what we do, we can look at a simple carbon budget. And we can see, using this simple carbon budget, the blue dashed line is the atmospheric CO2 level above the 1850 baseline. The blue line is what we're actually emitting. So the key takeaway here is that we're emitting twice as much CO2 as is showing up in the atmosphere. What's going on with it? That means the Earth is naturally sequestering. That remaining 50% of our emissions are being sequestered naturally by the Earth and Earth's processes, mainly by a great increase in photosynthesis, which is a good thing. There are a number of other ways that Dr. Engelbein will be doing this, looking at carbon ratios, isotope ratios. But again, that paper hopefully will be coming out within the month, right, Ferdinand? And so we've heard that volcanoes emit huge amounts of CO2. They do, but it's in a short time frame, and it compares very low compared to our emissions. Dr. Roy Spencer prepared this graph for me, showing that the red line is what actually happened with CO2 after Mount Pinatubo exploded. It's been said that Pinatubo put out more carbon dioxide in that one eruption than all of man's emissions. That's just not true. We know pretty closely what we emitted. We know pretty good idea what Pinatubo put out, and CO2 atmospheric levels actually dropped. I'm not going to go into the details of why, but Roy Spencer relates it to increased photosynthesis, sucking it more out. So don't believe the story that volcanoes are the big emitter of CO2. They aren't. In climate science, long term, I'm a geologist, so I like to look at the big picture, and I find most of my colleagues that are geologists are some of the most skeptic of all the scientists, because we look at the big picture. Long term is important. And if we look at this over the last 600 million years, we see that the average levels of CO2 in the atmosphere was 2,600 parts per million. Remember, we're at a little over 400 parts per million today, so the average was 6 times what they are today. We're actually at 400 parts per million. We're actually CO2 impoverished. We don't have too much CO2. We don't have enough. And if we took a look, this is one of the most dangerous charts in my book. It should be scary. What it's showing is the last 140 million years, a dangerous decline in carbon dioxide levels in the atmosphere. The red dashed line at the bottom is what I call the line of death. And that below that, which is 150 parts per million, plant life can't survive. We nearly got there 18,000 years ago at the end of the last ice advance. So we were within a whisker of getting near to that line of death. And it's because now we're liberating, thankfully, a lot of CO2. We're getting that back up to more normal levels, but we're still nowhere near it. We're still CO2 impoverished. This is the Hadcroot 5 database showing that temperature back to 1850, showing that we're in a long-term warming trend. But the important thing to look at here is that the warming trend we're in actually started more than 300 years ago. So this warming started at the end of the 17th century, in the middle of the coldest period of the last 10,000 years, the Little Ice Age. And so we've been warming ever since. We'll see in just a minute, we'll compare that to carbon dioxide, and we'll see that the first 250 years of this warming had to have been naturally driven. But we're being told now those natural drivers have ceased. They haven't. They're still in action today, just like they were 200 years ago and 300 years ago. And then we'll take a look at carbon dioxide versus temperature. This is what we're being told. CO2 is driving harmful warming. Unprecedented and unusual warming is the primary driver of temperature. Well, let's look at that. Just as remember I said in the middle of the 20th century, we started adding a lot of carbon dioxide to the atmosphere. Well, I grabbed this period from 1944 to 1976. We went into, just as we started increasing CO2 in the atmosphere, we went into a 33-year cooling trend. How do you explain that? If carbon dioxide is going to drive temperatures, why for 33 years did we experience a cooling? So this is just decades worth of data. And again, we just looked at this Central England temperature record that goes back to the year 1659. It's the longest thermometer record that we have. Again, red is temperature, blue is CO2. If I had to show one person, one chart, this would be it. If you have one choice to show them this. Show them the warming, the 250 years of warming that began before we started adding CO2, and explain that. You have to explain that 33-year cooling while we started in the mid-20th century. How did that occur? Why do we have 200 plus years of warming with very low CO2? And again, looking at that chart with a little greatly compressed y-axis. This is the same data. Again, it makes it even more stark of this increase of CO2 with virtually no effect on temperature. We go back a little bit further, 1,000 years. We look at back to the medieval warm period. We'll talk about that in a moment. And find that the medieval warm period, yes, it was warmer than today. It was at least as warm as today. Most likely, the facts show us, the research shows it's probably a lot warmer. We see the Little Ice Age, and we see CO2, atmospheric CO2 in blue. Again, if CO2 is driving temperature today, what drove the temperature 1,000 years ago? And even longer, we have what's called the Holocene conundrum. Looking over the past 8,000 years of data, the red, of course, is temperature, the blue is CO2, and over 8,000 years, what have we seen? Slowly declining temperatures, slowly increasing carbon dioxide, completely opposite of what they're claiming. And if we look at this, we can see now in decades, hundreds, thousands, and then we can look at millions of years, which I'm not showing you. We see no good correlation between CO2 rise and fall and carbon dioxide rise and fall. In many cases, just the opposite. One of the things that really fascinates me that did a deep dive into my book is the strong relationship between human history and temperature history. I find it fascinating. And the book that is available out there is in 3 sections. The second section is dedicated to this relationship between temperature rise and fall and the rise and fall of great civilizations. And if we look back, again, back to the first great civilizations that occurred during the Bronze Age, it was the Minoan warm period, the Hittites, the Babylonians, the Assyrians, the Harappan Empire in the Indus River Valley, and the Chinese. All these first great civilizations rose up in this Minoan warm period that was really warm. And we know it was warm again from proxy data, but we can go back to historical data. For example, they were growing a crop called millet in Scandinavia. You can't grow millet there. It's only there now. It's only grown in semi-tropical areas. And we can take evidence like that to show it was a lot warmer. And so all these great civilizations rose up. Food was bountiful, and then it started getting cold. And they dove into the Great Dark Ages. And it was called the Late Bronze Age Collapse. And you can search for that, Google it, whatever, and you can confirm within 50 or 100 years, all of those great civilizations collapsed, one upon itself. And again, during the warm period, they had a lot of food and it started getting cold. And the repeated story that history tells us, cold brings on crop failure, famine, pestilence, and mass depopulation. We're being told fear the heat. History tells us fear the cold is what we should fear. And so there were many centuries, and it was called the Greek Dark Ages, of this cold period. Life was really bad. This is repeated time and again. So if we had a Marcel Croc that was an empire, he was Emperor Marcel in a warm period, he could feed his subjects. And I think he would make a pretty good emperor, by the way. But he would be able to feed his subjects. Everybody was happy. But if you're Emperor Marcel, as you started going into the cold period, you were in trouble. You can't feed your subjects. They get not too happy. And that's what we see. They ran these emperors out of town. The empires collapsed. The Roman warm period was another great period of warming. We know that it was a lot warmer. They were growing citrus in the north of England near Hadrian's Wall. And of course, you can't do that today. And then again, we started cooling down. We went into the Dark Ages. We talked about the medieval warm period being warmer than today. And then when it started to get cold, really bad things happened. Again, crop failure, famine, pestilence, mass depopulation, just like the other periods. So what I did here, I took a look at historian Pfister's. They were showing here, the top chart is the number of witches killed per decade, and the bottom chart are extremely cold months during the summer months. And we can see as the colder it got, the more witches they killed, because it was it's human nature. If something bad is going on, to blame it on someone. And so they blamed them, this, and the troubles on weather-causing witches. And it's fascinating. They kept great records of the witches and reported, because there was actually a papal bull issued. The Pope said, witches cause bad weather, so if you find them, you need to kill them, and they did by a lot. And it really didn't get better until the end of when it started warming up again. What was funny, it was around, let me get back here, I believe it was around 1520, it warmed up again for 40 years. Crops came back, life was good. Why did it get better? Why did it warm up? Willie, they killed all the witches, is what they said. And this is the reason it only lasted for 40 years, but then it really started getting cold. And so it's kind of a funny tale, but it's not, especially if you're accused of being a witch. But it's a tale that tells us, again, cold is related to bad things. And so if we learn anything from this little sojourn into human history and temperature history, it's that human history tells us, again, that we should welcome the warmth and fear the cold. So these people, these climate alarmists, the climate cold, they call me a science denier. They call somebody like Dr. John Clauser a science denier. We should call them history deniers, because they're denying what history tells us. History and medical profession tell us too. We're being told that extreme heat and increasing heat because of our emissions of CO2 are going to kill people. It's going to lead to crop failure. It's going to lead to massive floods, massive droughts. But just the opposite we find, and higher death rate. We find, this is the chart from Dr. Antonio Gasparini, the largest study of its kind. They looked at 74 million temperature-related deaths from 14 different nations. These were cold nations, warm nations. And they found, Gasparini and his team found that 20 times as many people die due to cold. The blue lines there are cold-related deaths. The orange charts are heat-related deaths. And so if we look at this, another study concluded it was 15 times as many people die from cold-related deaths as heat-related deaths. 15, 20, a lot more people die from cold as from heat. So what does that tell me? Global warming will save lives. It just will, as we increase temperatures in the coldest periods. If we look at extreme weather and natural disasters, this is UN reported data from Our World in Data. It's from the International Disaster Database out of Belgium. And what they did was this was reported as a 5-fold increase in natural disasters, because they started the data here in 1970 on the left, and they started building out these stations. But it took them until the year 2000 to really have all the stations built out, have enough. And from 2000 on, there's been a 10% decline in natural disasters. But the UN, when they issued this, they reported it as a 5-fold increase from 1970. I contacted them, and Kip Hansen, one of our members, also contacted them, and they agreed that, well, from 1970 to 2000, that was really not an increase in disasters. It was an increase in the reporting stations. So they're reporting more disasters, not that there were more disasters. And they said, you should just use from 2000 on. But that's not what the headlines read. The headlines blared 5-fold increase in natural disasters, and of course they linked it to global warming. The big thing too we see is global deaths from natural disasters have been in a significant decline, huge decline. From 1900 to recent, the last decade, we've seen a greater than 90% decline in global deaths from natural disasters. Granted, it has a lot to do with better reporting. In the United States, they would say, well, there's a Category 3 storm about ready to hit Corpus Christi, Texas, you better bail out. And they can give that reporting ahead of time. So we have better warning systems, tornado warning systems. And so a lot of this is not attributable to really a decrease in disasters, but that doesn't hurt. Again, drought. is globally in a significant decline. Drought is the number one natural disaster in terms of lives lost and economic productivity. Droughts are, throughout the last several thousand years, are the number one natural disaster. They're just horrific. Thankfully, they're in decline. Part of it is we're seeing a modest increase in precipitation, but we're also, and that's globally, but we're also seeing that increased carbon dioxide fertilization effect means that plants require less water. So they're better able to resist drought. And we're seeing that as reflected in the southern Sahara, the Sahel, where 200,000 square kilometers of former desert are now greening, turning into a lush grassland. And so we have this CO2 fertilization effect is pushing back against water needs for plants. Global area burned. This is from the Copernicus satellite. It was launched in 2003. We finally have a good database and a good summary. We can look at area burned globally and have it accurate. And this is from, again, Copernicus 3 database showing a significant decline in area burned. And of course, here in the Netherlands, I don't have to tell you, are we underwater? Are we below sea level here? Probably. So you're concerned about sea level rise, and you should be. But as you probably have seen, and we're going to talk about some of this from sea level rise, it started sea level, if CO2-driven warming is causing sea level to rise, we should see that reflected sometime in that period from 1950 on. So this is glaciers that started worldwide, started retreating in the early 1800s. But we didn't start adding CO2 until the mid-20th century. So we had 150 or so years of retreating glaciers prior to addition of CO2, and we see no acceleration of that. And here's global sea level rise. And we see again here in the mid-1800s, sea level rise started occurring, and of course that's because of melting glaciers, melting alpine and land-based glaciers. And you might ask yourself, well, why did it not start rising and glaciers start retreating when we started warming? Because it took that long to get warm enough that summer ice loss exceeded winter ice accumulation. And here we are at, I'm going to mispronounce it, Harlingen in the Netherlands. The thing to look at in these other graphs we're going to look at, is there an acceleration since 1950, mid-20th century? Is there an acceleration in sea level rise that we can be reflected here? We don't see it here. And I guess these are tide gauges. It's the best long-term measurement of sea level. These go back to a lot of them late 1800s, mid-1800s. I took a look here at the 6 of the world's largest cities, what's happening with the sea level there. Look at that. Do we see acceleration of sea level rise? No. It's rising at about the same rate as what it did in the late 1800s and the mid-1800s. So is sea level rising? Yes. Is it due to warming? Yes. But it's not being driven by CO2 increases in temperature. And the UN reports that the Maldives are our most at-risk island chain. The highest point's 14 feet above sea level. Well, let's think about this. The Maldives in the Indian Ocean, 18,000 years ago, they were also just above sea level. Since 18,000 years ago, sea level has risen 400 feet. Why are these islands not under 400 feet of water, you might ask? Good question. And it's because of a geologic process known as accretion. And again, you can look that up, look for islands and accretion. And it's a geologic process that as sea level rises, the near-shore sediments are washed, and during storm events, are washed up onto the island, moved around by animals, but they grow and grow and grow. Otherwise, all of these islands that are now just above sea level should be under 400 feet of water. And people don't know this. This is not widely reported. We take a look at probably the greatest benefit we see from modest warming and more CO2 is a greening of the earth. You've all seen this. This is regular fare for every talk. This is the greening of the earth by NASA. We see here too that crop increase, the red line is food production. The blue line in the middle is global population, and the orange line is the land required that's under agricultural production. And we see that food production is greatly outpacing population growth. So much for this Malthusian philosophy that we have too many people on Earth. So we're feeding more people. We're feeding a growing population. And one of the reasons we see is modest warming. This is a chart of the length of the growing season in the continental United States. And it'll be similar here. In the continental United States, the growing season has increased by more than 2 weeks since 1900. That's great news for farmers. Killing frosts end earlier in the spring, arrive later in the fall, so we can get more plantings in. And I took a look at, this is from my book, I took a look at the top 8 crops worldwide in terms of tonnage. Look at them. All of them breaking records year after year after year. And it's attributed to mainly 3 things. Warming, CO2-driven fertilization effects increasing, and nitrogen fertilizer. And everyone here from the Netherlands knows about the one of the satanic gases is nitrous oxide and then nitrogen fertilizer. But nitrogen fertilizers might be responsible for 30% or more of worldwide crop increase. And here, if we look in the Netherlands, I took a look at crops here. Again, it's the same here as we see worldwide. Crops breaking records year after year. It's been a wet year, I hear. But I wish I had known that, to look at that, put the precipitation records into the long-term record to see what that, I suspect we would have other wet springs similar to what we're seeing here now. And I got to tell you, let me see how much time, I've got a few minutes. I've been so impressed driving around this country. I'm from a farming background. I grew up on my granddad's farm. We had Holstein cattle and raised corn. And I'm just so impressed by it. There's just so much agriculture here in this country. It's truly amazing. We took a look here. This is United States corn production. The black line is corn production. The blue line is atmospheric CO2. The red line is temperature. Look at that. Temperature goes up. CO2 level rises, and corn growth breaks records year after year. So I want to finish up here just a little bit earlier, but the main fact here is life is good and getting better. We did a focus group at the CO2 Coalition with 1,000 people last year. What's moving? What do people respond to? And it's a positive message. They want to hear a positive message about what's happening. And I think all of us, as we talk, instead of just saying there is no climate crisis, that's being reactive. Let's be proactive. It's not, yes, there is no climate crisis. I get that. That's easily disproved. But we've moved beyond, in my new book, I've moved beyond there is no climate crisis. I've moved to that what we're seeing here, embrace the warmth. It is warming and has been for 300 years. Embrace the warmth and the benefits, and embrace more CO2. So I'd encourage you to spread that message of benefits. I live a high carbon lifestyle. I heat my home with natural gas. I cool my home with electricity that's mostly derived from coal. And I keep my home comfortably cool in the summer and comfortably warm in the winter, and drive a gasoline-powered SUV. And I like to eat a steak every once in a while or more. And so embrace that high carbon lifestyle, because the carbon you're emitting, it's not really carbon dioxide, is showing to be a huge, huge benefit. And so we should celebrate that. And thank you all for this. Appreciate it.
Thank you very much, Gregory, for this great speech.
Thank you.
And I want to congratulate you with your first Dutch translation of your new book.
Oh, thank you so much. Look at that. Are these available out front?
Now, only just a few, I think.
Oh.
Everybody wants this book, of course, you understand.
I do. I know how that goes, yes.
So thank you very much.
This is wonderful. Thank you so much. Thank you, Edward.